With what? Refreshment? Alright.
Alright, here we go. Alright, so we have an elastic object in the bell, and we have an object that is a little less elastic. And we're going to turn the pump on, and we're going to see what happens, okay?
Oh, is it gonna be gravity?
Because there's less room, so I can.
Oh, because there's no air pressure on it.
Wait. So for parties, I can blow up a balloon like this?
Oh my god.
Hold on.
It's gonna pop, guys. It's because there's no air pressure to hold it down.
Yo, remember the glass?
I'm gonna cry if this pops. I have a heart attack.
Stilwell.
Stilwell, this gave me highly unsure of my life anymore.
There was helium in the balloon. You did that.
Oh my God.
It wouldn't be any different.
Let it pop.
Yeah, let it pop.
Okay.
I'll provide you with another balloon.
All right, so the first thing we have to explain is what changed?
The air pressure outside.
No. What changed in the balloon? This is our system. We have two systems that we're looking at: the balloon and not the can because the can's open, and the bottle. Okay. Now,
Is the bottle closed?
everything that's outside of the balloon is the universe that the balloon is in. The balloon is the system. Everything that's outside of the bottle is the universe that the bottle is in. Right? We change the conditions of the universe that they're in. Right? You're looking at the balloon. So what changed? What aspect of the balloon changed?
It expanded.
So what word do we use for that? What's greater?
Oh, there's less pressure.
Remember, there was three things we're looking at: pressure, temperature, volume. Didn't the volume of the balloon change?
Yeah.
So we need to explain the volume of the balloon based on everything else. Did the temperature change?
No.
Not appreciably, right? We're at room temperature. We didn't add heat, remove heat. But the volume changed, and we need to understand why. Yes?
Wait, I have a question. Is the balloon is tied off, right?
The balloon is tied off.
But doesn't that contradict the first task where when we closed it off, there was no air going in and no air going out?
There was no air going in and no air going out.
It's tied, Mark.
Oh, so it just got bigger? I thought air just went in. No, it just got bigger naturally.
Yeah, like.
Well, wait. No, listen. This is exactly what this is all about. It's about asking questions, right? So don't jump on the guy that's asking the questions. He's the one that's doing what we're all supposed to be doing. All right, so you're asking now what? We saw that the volume changed. We said that we weren't going to change one thing. What did we say we weren't going to change? No. We talked about inflating a tire, right? You get a low tire in your car. You go to the gas station. You put air in the tire. We said that's the thing that we're not going to do, right? The amount of air that was in the balloon is still the same amount of air that was in the balloon before.
Same amount of air.
The same amount of air. The balloon is closed, right? What I changed was the universe that the balloon is in. That changed. So the volume changed. Okay? So now let's watch what happens when I open the valve and let the air back in.
Wait, can we let it expand all the way?
We can, but this is enough. Watch.
Wait, so
That's a little creepy.
It is something.
Wait, you guys notice the water inside the water bottle?
Like everything, like
The water in the water bottle is the best.
no, that can't bottle.
Okay, I have to try the nothing appreciably happened to the bottle.
Yeah, I wanted
to
it
touch it.
It's cold.
Oh, it's.
Okay. All right, so it returned to the way it was before, right?
Right.
All right, so you now are going to discuss what happened and try to figure out if you have a good explanation for what happened. How would you explain what happened? You saw that what increased? The volume, okay. And when you let the air back in, the volume went back down to what it was before. So you're not going to share with the class, you're going to share with your group, okay? And I'm going to come around and talk to you all.
Is it bad that I don't answer any calls even if somebody's
So outside.
Yes.
So you know how like was it that that vacuum was like sucking the air, so it made the thing like stretch, like when you stretch it like that. And is that the reason why it became bigger? Because you said that the amount of air that it was before it was the same.
Well, do you think logically the air could have changed if the balloon was tied together?
I made sense. Come on.
I mean,
The balloon is closed, then no air is going in and no air is going out. But you saw the volume change.
yeah, but it's.
So you have to explain why.
Is it because like okay, so is it because the balloon was like being stretched because there was more space, like when before the pressure of the air that was outside was like keeping it
Right,
small?
but try to explain it in terms of collisions. Can you explain it in terms of collisions? So see what you're thinking, discuss it in your group, and think about what's going on in terms of the collisions that are
But is
involved.
that the reason why?
I want you to try to figure out the reason. We're going to discuss it afterwards and then we're going to be looking at it a different way. So, but first we need to figure out what it seems like to you.
It seems like the balloon stretched because it took like the space that the air was taking before. So like then it stretched and took the space that was
All right,
out
so
there.
explain it to the two of them and see if they agree. So what do you think?
Well, like I blew up this balloon for demonstration. So all the air in the room, right now is playing as a factor of pushing this balloon down. If we were to take all the air out of this room, then there's nothing holding the balloon down, so it could keep expanding as much as.
Okay, so now explain that in terms of the collisions involved. There's air hitting the balloon on the outside, right? And there's air inside hitting the balloon on the inside surface. How does that change when you remove air on the outside? Okay. Any insights?
Say what you were saying.
Yeah.
The air was sucked out of the
Because
valve.
they're pushing out.
The pressure that was on the balloon
that outside.
lessened, and then the air inside the balloon expanded to fit the new space.
Okay, can you explain that in terms of collisions?
If you're stretching, right, and you're in a box.
All right, so why don't you guys think about a way of explaining what he said in terms of all the collisions involved. That's why I had you play with the balloon first, so that you know how the balloon behaves here in the outside, and then in terms of what happens inside the bell. All right, so you played with the balloon before, right? Yeah. Out here. So I want you to see if you can explain what happened in the bell in terms of collisions.
So after you took out the air pressure on the outside of the balloon, right? This allowed the balloon to expand because there was no opposition to the balloon on the outside, so there was really no collision. So the air.
Wait. So just say it more specifically. What was happening on the outside?
On the outside, the air pressure was being extracted, was it not?
So what was happening on the outside of the balloon in terms of collisions?
There was less collisions.
Because there was less air.
Yeah.
Okay. What was happening on the inside?
On the inside of the balloon, all of it was dispersing to the sides of the balloon, allowing it to increase in volume.
But
Since
why,
it was-
why did the volume change? Why
Because
did,
the air was not being contained anymore because there was no pressure outside. Therefore, it was allowed to like expand.
okay, so say the same thing in terms of collisions.
With no collision happening outside of the balloon environment, the balloon was allowed to expand.
What was happening on the inside in terms of collisions?
They collided to the walls of
Yeah.
the balloon. The walls of the balloon, allowing it to expand and bottom.
All right, so write that down. How are you guys?
theory. I have
You
a
came up with a
theory.
discussion? Yes?
I was thinking because since like density, ultra with mass and volume, maybe the fact that the density decreased, that increases the volume with it in mathematical terms if you had all this.
Well, the density does decrease, but
Yeah.
can you explain it in terms of collisions? Because we're looking at the gas particles, and we're trying to figure out how it is that we're trying to explain how gases behave. So, and we say gases are particles; they move in straight line motion, they collide, right?
Yes.
So, can you explain what you just said in terms of the collisions of the gas particles? So discuss it with your group and come up with an explanation you can write down in terms of collisions. Magic.
Voila.
That's always a good explanation, right?
We said that basically we said the air pressure coming from outside.
Guys, the volume's too high, I can't hear. Thank you.
We said that air pressure coming from outside prevents the balloon from expanding, and then inside the belt, the air pressure was decreasing, so allowed the air in the balloon to expand, basically.
Right? Can you explain that in terms of collisions? Because we're thinking about gases in terms of particles.
Yeah.
So the idea is, can we think about, can we say what you just said in terms of the collisions that are happening on both sides of the wall of the balloon before we take the air out and after we take the air out? We know that the volume increased. We're trying to answer why does the volume increase in terms of the collisions on the outside and the inside. So finish your discussion and then write something down.
Outside and inside.
The same collision.
Bye. Cause I was thinking, Mr. Stilwell, I was thinking like, okay, so there's an equilibrium from the particles inside the balloon and outside the balloon. I know her. Yeah, with the air, no particles outside, so that make it more expanding. That's why.
So in terms of collisions, there's fewer collisions on the inside. The ones on the inside stay the same.
That was why when they grow and grow. I was just saying it. I was like,
So say that again. Say that again.
wait. Okay, so the particles inside the balloon and the particles outside the balloon. That's why when you blow up a balloon here, if I blow up a balloon now, it would just stay in place. It wouldn't like grow or demolish or something. But when you took out the air from the balloon, took out the air outside the balloon, there was no like collision and pressure to hold the equilibrium. So that's why the air particles inside kept circulating and expanding and expanding and expanding. What?
Okay. Wait, and then we reached the new equilibrium when I stopped the pump.
Yeah. Oh, you want me to explain the other way around?
No, I'm just saying. Because then once I stopped the pump,
It
stayed.
it stayed in that equilibrium. There was like that much and there was not much. Like if you kept going, it would kept growing.
And then what happened to the collisions inside and out when you let the air back in?
And when you let the air back in, it was growing more. So that's why it was like getting smaller, because since you're adding more air from the outside, it got smaller. I'm so smart. What? I actually understand it. I was just mumbling words.
Okay, good. Excellent. Yes.
Oh my god.
I told my friend about this.
Uh-huh.
He wants to come and sit here and watch us.
He wants to come
He
and
is
see.
free. He is free.
We'll see.
All right. He's gonna be at the door.
There's more to learn, everybody. All right, remember, we're going to do this. We're going to look at this again, and I'm going to guide you through a careful way of looking at each of the three variables: temperature, pressure, volume, and we're going to analyze how they're changing. We're going to discuss each change that we saw in terms of collisions to compare the explanation I'll give you later to the explanations you're writing now. Okay? That's the whole point. Okay, now, I'm going to give you a soda can. And I'm going to stop the, this is going to take a little while to set it up. So.